Hey there, Kipsters. We're looking at objectives 1C.1 through 2, rational and irrational numbers. In order to explain this, I think the best way I could explain this is just really by showing you the universe of numbers. This is not all the numbers you'll look at through college, but most of the numbers you're going to look at until very late high school are going to fall in this universe of numbers that are either rational or irrational. When you think of a rational number, the key word is ratio. You're trying to find numbers that can be expressed as a ratio. So what I'm going to do is, you see all these numbers on the bottom, I'm going to group them into either rational or irrational numbers based on whether I can turn them into a ratio of integers. That means a fraction that has an integer on the top and an integer on the bottom. So this first one, 5, is a rational number because it can be expressed as a ratio. 5 is the same thing as 5 over 1, which is a ratio. So whole numbers are rational numbers. The second one you see, 1/2, is definitely a rational number because you should see it already is a ratio. 1 over 2. So again, it's a rational number. Fractions are rational numbers. The third one you see here, 25/100ths, is a rational number because it can be expressed as a ratio. 25/100ths is the same thing, 25 cents, as 1/4. So a decimal that terminates, let me make some notes here, let's see. Decimal that terminates is also a rational number. The next one you see here, this repeating decimal, is a rational number because it can also be expressed as a ratio. 0.33333 is the same thing as 1/3. If you were to divide 1 divided by 3, you would get 0.333, and it would go on forever. So they're the same thing. So a repeating decimal is also a rational number because it can be expressed as a ratio. The next one you see here, 10%, is a ratio because you can express a percent as a ratio. 10% is the same thing as 10 per 100, 10%, which actually simplifies to 1/10. Again, a ratio. And the last one you see here that would be a rational number, and at least for what I'm going to talk about, is -4. And a -4 is just a rational number because it also can be expressed as a ratio. -4 over 1, that's how you would write it as a fraction. So you kind of generalize about this. There's some things you see in this category. You see whole numbers, that's the first one. You see fractions. You see terminating decimals, decimals that end, I'll just write termin decimals, such as 25/100ths, because it can be written as a ratio. You see repeating decimals, like 1/3 or 0.33333, because it can be expressed as a ratio. You see percents, because that can be expressed as a ratio. And you even see integers, like -4. All of these are rational numbers because they can be expressed as ratios. There are a couple numbers here that cannot be expressed as a ratio. They're not a whole number, they're not fractions, they're not terminating decimals, they're not repeating decimals, they're not percents, they're not integers. First example you see here is a number you might recognize, 3.14159265535, and the number keeps going. Hopefully you recognize that this is the first several digits of the number pi. This is an irrational number because you cannot write it as a fraction of 2 integers. It is only going to be a decimal that continues forever, so it doesn't terminate, and there's no pattern to it, so it doesn't repeat. And so you have a non-terminating, not repeating decimal that is an irrational number. I have one more example that I'll give you, which is a number like 0.10100100001, and it goes on. Again, it doesn't terminate. Doesn't terminate, that means it never stops. And it doesn't repeat. And those are the two examples that I'll give you of irrational numbers. I want you to stop the video here and please group the last 6 numbers you see in the bottom right hand corner and label them as either rational or irrational. Stop the video here and press play when you're ready to check your answers on those 6. Okay, you've grouped those 6 numbers. Let's see if you got them right. So this first one, negative third, is a rational number because it can be written as a ratio. I'll do this in green so you can see it. Negative 3 over 1. The second one, 2/10 is a ratio, a rational number, because it can be expressed as a ratio as 2/10. The next one, 0.666, is a rational number because it can be expressed as a ratio. 0.666 repeated, I know is the same thing as 2/3. If you divided 2 divided by 3, you would get that decimal. The next one, 50%, is a rational number because that, again, can be written as a ratio as 50 over 100. Next one, 4/5, is a rational number because it already is a ratio. And that last one, 12, is a rational number because 12 can be written as a ratio 12 over 1. They were all rational numbers. I think it's time for you to practice, and you can definitely go back to this slide to get some more ideas. But I'd like you to identify each of these numbers as rational or irrational. There's 10 problems here, and these are the 10 that you're going to submit online. Make sure that you write the complete word spelled correctly as either rational or irrational. You see that it has 2 R's. Good luck.